All right, 7th graders, we're going to continue with lesson 8.2. 8.2 has a lot of stuff in it. And so we're going to spend a couple of days on this lesson, and then you're going to actually take a quiz tomorrow on this, just on this lesson. Okay? So yesterday we talked about how to graph a line. Why do we need to graph a line? John? Okay, good. Yeah, that's an application for a line. A line gives us a bunch of numbers that go together. Those are called ordered pairs. They're pairs of numbers that where one is the x coordinate, one is the y coordinate, and the numbers together make an equation. What? True or false? They would make the equation true. Okay? And we're looking for those numbers. That's why we need a line. Because there's an infinite number of possibilities. There's an infinite number of combinations of numbers that could make an equation like this true. So we did this one yesterday. It's to graph this equation in order to find numbers that will go together to make the equation true. We chose some numbers for x. We chose 0, and we put 0 into the equation, and found that when you substitute 0 for x, you get -2 for y. In other words, those two numbers together, working together, make the equation true. If we substitute 1 for x, what's the y value? Look up here. What's the y value when we substitute x? Joey?
The y value is
What's the y value for this number?
Oh, -3.
-3. So when we put 1 in for x, it equals -3. If you put in 2 for x, what's the value, Noah? What's the value? No. -4. Okay? And this on a chart gives us a set of points that we can graph over there. And then we talked about this graph a little bit. After we graphed these points, what did it form when we connect them using a line? When we connect them, it forms a line, a straight line in this case. This is called a linear equation because it forms a straight line. That's what that term linear equation refers to. It will always refer to a straight line. Okay? Now, if we have the straight line, that means we can find other points. And that's one of the application things that John mentioned. That's one of the reasons why you graph a line, is to find or predict what other points would be. And then we learned about the spot that it crosses the x-axis. The spot that this line crosses the x-axis is called the what? X-intercept. In other words, where the line crosses or intercepts the x line. This is the x line, the x-axis, and this is the y line, the y-axis. Right? You with me yet? Okay. What would it be called where the line crosses the y-axis? Kira?
The y-intercept.
The y-intercept. Yep, the y-intercept. We're going to talk more about that later on. Okay? So, that's our goal, is to be able to graph this line. Be able to tell where it crosses the y-axis, the y-intercept. Alright, that will be useful later. Let's go to some more from this lesson. Well, wait, let's go through your assignment for today first. Okay? Number 12, you did number 12. It was y equals x minus 3. So our procedure was to do what? To make a T-chart. to choose values for x and to graph the equation. So, what numbers did you choose? James? 1, 2, and 3. So we should write those in on the chart. Alright? You may have done all the work on this, on the sheet that I gave you. You could put all of this work underneath or next to one of these graphs. Okay? Now, when we substitute it, if x is 1, what is y? Dylan? -2, yep. If x is 2, Henry?
Since it's negative x. Oh, it's not x.
Oh, not a number 12 it isn't, no.
Oh, it'd be
-1. And if x is 3, y is 0. And we put these points together. -1, 0. So this forms some coordinates. 1, -2, 2, -1, and 3, 0. Now, I want you to notice something. When we graph these, our graphs, our points were, what were they again? Whoops. 1, -2, 2, -1, and 3, 0. Remember those. 1, -2, 2, over 2 down 1, 2, -1, and 3, 0, right? So right on the line. Right? Now, you may have found other points.
Yeah.
You may have found this point, or this point, or this point, or this point, or this point, right? You could have found any of these points as part of your solution or when you're working this out. Why would those work? Why would those work? Isaac?
because there's one x and every y.
Okay, and they're on the same what? They're on the same line. They form the same line. Okay? So, our solution is not necessarily these 3 points. Our solution is what? It's the line. It's this line. The line is the solution for the equation. Okay? Your line has to cross, or has to have the y-intercept at what? Where's the y-intercept in this equation? 0, -3. Or just, you can say the y-intercept is -3. The x-intercept is 3. Yep. The x-intercept is 3. The y-intercept is -3. Any questions on that? John?
Do you have to do that whole process? Because I just wrote down a number and then I did the equation. Like, I just put down 3 and then that 0. And I just put down a number and then I did the other one.
Mm-hmm.
Do that.
And did you get this line? Did it cross at -3 on the y-axis and 3 on the x-axis? Yep. Because the solution is the line. Okay. Number 13. The equation is
It's
What?
y equals
-2, right? Now what? What should we do next? Dylan? What should we do next to graph this? Find our numbers. What numbers should we use? 1, 2, 3? And then what? Go ahead, keep going. You're on a roll. Yep. And we have to put. Yep. So we keep the negative, and we just substitute this for x. Always put the number in just for the x, not for the negative sign, just for the x. So this is -1 plus -2, or -1 minus 2, which is what? -3. 2 in for x. So -2 minus 2 is -4, and 3 in for x. -5, yep. So, -3, -4, -5, right? Now let's graph these. 1, -2, right? Oh, 1, -3, I'm sorry. 1, -3, 2, -4, 3, -5, right? How is this line different from the other line? The other line was going through like this. What do you notice about the slant of the line?
They make an X.
One of them goes down as it goes to the right. The other one is going up and to the right. When you're describing a line, you describe it as a positive correlation or a positive slope or a negative slope. And a negative slope goes down to the right, a positive slope goes up and to the right. Okay? Questions on that? All right. Number 14. Michael. Y equals
X
minus 2. Now what?
And then I started making a chart,
Yeah.
and I put in -3, -5, -6.
-3, -5, and -7. Okay. Let me give you a one that you should always use. Use 0.
-3, -9.
Should we skip -7?
Yeah.
Okay, let's skip -7.
Go back.
Yep. The other one that is really helpful, John, pay attention. The other one that's really helpful to use, especially with fractions, is to use the denominator if you have a fraction, or the multiple of a denominator. All right? Because it gets rid of the fraction. Okay? So, -3 is fine, that'll work, because that'll get rid of that. Okay? Let's try 6 also. Let's see if that gives us some nice whole numbers to work with. Let's start with -3. So 2/3 times -3 minus 2. Chase?
Yes.
What's that?
That would be between the cross out the 2.
So we got -1 here.
That'd be 2 over 1.
Negative, this would be -2 minus 2 is
-4.
-4. So -3, -4 works. Okay. What else? -5. Can we use that? Let's try -5 and see what happens. If we substitute -5 here, it'll give us a number. Might not be a number that we want to use, because we're going to have a fraction, aren't we? 10/3, or sorry, -10/3. plus negative 2. Okay. Then we'd have to convert this to thirds. Alright? Let's just skip this one altogether.
I
Let's
just,
skip
I
this
did
one.
it.
Feels like the only one
You
that-
can, yeah, yeah.
Two zeros,
I'll
2
do
0.
that.
Since we're allowed to pick any numbers we want,
I can do
let's try 0 and see how that works. 2/3 times 0, oops, minus 2 equals what, Dylan? This is 0, so it's just negative 2, yeah. So that's good. Oops, not 5. 0 and negative 2.
Use the 6 to 9.
Try the 6?
Yeah,
Let's try the 6. 2/3 times 6 minus 2. So that we can, Keyshawn, what's this? No, focus. Two, right? So then 2 times 2 is 4 minus 2 is 2. So for 6 goes with 2, right? Can you see over there very well? I think you should move over here. Alright? I think I'm in your way and that's why you got distracted. So I'm going to move you over there later, okay? Alright. So remember these points, okay? Remember these points. Okay? Negative 3, negative 4, 6, 2, and 0, 2. Negative 3, negative 4, 6, 2,
negative 2.
6, 2, and 0, negative 2, right? Yeah.
I think so.
Now, I might need a ruler to do this. Oops. Math rules. So let's see if I can. What are Yeah, that makes a line, doesn't it?
Kind of.
No, it doesn't.
You have to put pressure against that?
Almost. This is really hard to do electronically.
Wait.
Alright.
It's off. It's good enough.
It's off.
10th of an inch.
But these points work, they form a line,
Sorry.
don't they?
No.
Yeah, they do.
I think that one should be down more.
Yeah, this one should be up a little more, and this one should be down a little more.
It actually lets you
Right.
like put pressure against it and like it won't drop past.
Yeah, yep. Okay, let's go on. So, we know how to graph lines. Okay? What if we just need to see if a point is a solution? What if it says, number 1 in page 412 again, find the solution for each equation when x is negative 5. So, to see if this, y equals 4x plus 2, find the solution. In other words, what they're giving you is x equals negative 5, and what are we trying to find? Find y. Yep. Find y. So what would we do with this, Isaac? What would we do with the x equals negative 5 to find the solution?
So about 4 times negative 5 plus 2.
Yeah, good. We would substitute the negative 5 in for x. 4 times negative 5 plus 2. What is y? Henry? 22.
No, negative 22. No, no,
Negative
no,
20 plus 2, right?
no. 18.
Negative 18. See, it's really helpful to show your work here. Okay? So make sure that you substitute it in. What did I do when I substituted it? What did I put it in? Parentheses, yeah. Always substitute using parentheses. Okay, this means 5 times x. So we have to do 4 times x. So we have to do 4 times negative 5. And the parentheses show the multiplication. Okay? So what is the solution then? If it says to find the solution, what is the solution for x is negative 5? It's the two numbers that make it true. So it's the what? The x and the y. What would we write as our answer then? Hunter. What would we write as our answer?
I was just not paying attention.
Okay, come on. This is a simple one. We have the x and we have the y. How do we write it as our solution? Hunter. If x is negative 5, what is the solution for this equation?
X is negative 5,
We would write negative 5, comma,
and negative 18.
negative 18. These two numbers go together to make a solution. Okay? So that's the first section of this assignment, of this lesson. Okay? The second part is what we just did in 12 through 14, to graph the equation. But what if the equation they give you is like this? Negative 4x plus y equals 16. Now, how are we going to make our chart and graph the line?
Plus negative y.
Yeah, we're going to solve for y first. Because that way, when we substitute x in, we can easily find what y is. So, just like James was saying, we're going to get rid of the negative 4x on this side. Add it to this side so that our equation is y equals what? Noah?
Y equals 12x.
No, we can't add these two together, can we? These are not like terms.
16.
Okay. 16 plus 4x, or we could write it as 4x plus 16, right? Now we have an equation to work with. Now, how are we going to use this to graph? What do we have to do to graph this now, John?
We have to split a number into x and y.
Yeah, let's choose some numbers. Nikki, why don't you pick some numbers for us?
1, 2, and 3.
Okay. What about my favorite one? 0? And since we have a big number here, what if we use some negatives in order to get some smaller answers? That works too. When you're thinking about graphing, you may not want to graph like numbers in the 30s or 40s. Okay? We have a graph that goes up to 20. That's okay.
21.
A graph goes everywhere in all directions.
I know, but.
All right. So let's pick 0. Always pick 0. Pick 0 because it's a good one to work with. If x is 0, what is y? 16, right? 4 times 0. So we'll start with that one. What else?
1.
1?
No.
1. 4x, 4 times 1. What would that be?
4.
Plus 16. 20. How about negative 5?
Yeah.
Negative 5, 4 times negative 5 is negative 20, plus 16 is, come on people, negative 4. So negative 5, negative 4. Now let's go to our graph. Graph these points. Where is 0, 16? Keyshawn? Yep.
What is it?
Here, this point.
I don't know. Where is it on the thing?
0's in the middle, but how would we find that on the graph? 0, 16.
You start from 0 and go down 16.
Is it up 16, right?
Yeah.
How about 120?
1 to the right.
Yep, 1 to the right. 20 up. Oops, I think I put that in the wrong spot. Here's the bold line. 120. And negative 5, negative 4. How would we find that?
Go to the left.
Kira?
Well, you go to the left 5.
Left 5 and down
Down 4.
4. Yep.
That's one side line.
Yep.
Ruler.
So my ruler.
That's yours.
I need to get there.
Move it over farther. Wait, are you trying to slant
I'm
it?
trying to slant it.
Move it over farther, like to the,
You gotta go to the edge of the room.
yeah, right there.
No, because that moves it
No,
outer
Red,
in.
Red, go
I
down.
need this thing.
7. You're pretty close.
Okay. So now I go this over
Down to close enough.
They've taken over ACT.
To the edge.
There we go. Oh,
Fail.
The other edge.
Great.
That didn't work. Computer does not like to work.
You need the bottom corner. The bottom edge. Now go down. Right there. This is so hard, Tim.
there we go.
They don't see
Yay.
Yep, it's on the line. Yep, these points work, don't they?
Yeah.
Close enough. Okay. Now, what do we have to put on the ends of our lines? Arrows to show that the line extends. This line extends all the way across. Okay? Alright, so we've covered all of lesson 8.2 now. We've covered how to check a solution, okay, or how to find a solution given a value. We have covered a couple of times how to graph equations. First, if it's already solved for y, then the first thing you should do is make a chart and choose some values. Okay? If it's not solved for y, then you need to solve it for y and get y by itself first. And then use those points to graph the line. Okay? There'll be a quiz on this tomorrow.